Here we have five small topics: identical cells and unidentical cells under two categorization. Overall, five types. First, identical cells, unidentical. Here, identical में कौन कौन से टाइप हुए? Series, parallel, mixed grouping. And here, unidentical में series and parallel. सबसे पहले आइडेंटिकल सीरीज लेते हैं. इनमें सबसे एकदम कॉमन सेंस वाली बात है. सपोज वी टेक लाइक दिस. और पहले ये भी हम लोग क्लियर कर लें कि आइडेंटिकल एंड अनआइडेंटिकल का के बीच में व्हाट्स द कंपैरिजन बिटवीन दीज टू टर्म्स. आइडेंटिकल का मतलब सारे सेल्स का ईएमएफ कैपिटल ई लेंगे. एंड उन सभी का इंटरनल रेसिस्टेंस स्मॉल आर लेंगे. बट इन केस ऑफ अनआइडेंटिकल सेल्स वहां पे कैपिटल E1, E2, E3 so on and on the same line small r1, small r2 and so on. अब यहाँ पे आइडेंटिकल सीरीज में एक सिचुएशन ऐसे हो सकती है n cells. So this is our current in the circuit. I is equal to NE. Since we have n cells in series, n cells. So this way I is equal to NE upon R plus NR. Condition for maximum current, R is equal to NR. Since in case of maximum current, always we need to consider total external resistance is equal to total internal resistance. Another situation, अगर इस तरह की सिचुएशन होती तो इस वाले एंड इन दोनों ने एक दूसरे को कैंसिल कर दिया और यहाँ पे प्लस माइनस बट दिस इज माइनस प्लस. तो इन दोनों ने ईएमएफ इन दीज टू ईएमएफ्स आर कैंसिल. तो फाइनली I is equal to only E is left, but this R plus 3R will be considered because EMF ने EMF को कैंसिल किया. रेसिस्टेंसेस तो है ही. तो ये डिस्कशन थी हमारी आइडेंटिकल सीरीज. नाउ कमिंग डाउन टू आइडेंटिकल पैरेलल. Now let us suppose n number of cells are connected in parallel and this is external resistance capital R E R plus minus plus so on E R. This is I. So I is equal to E because in parallel potential difference remains same. Since these were identical cells, so E will remain as it is E only. And capital R plus R by N. Condition for I max R is equal to R by N. ये भी बात हो गई. Then identical mixed grouping. इनमें अब हम लोग देखते हैं. पहले डायग्राम लेना होगा. n number of cells in series. Of course ER and here m identical rows. और इस तरीके से this is R और यहाँ से आपका करंट निकलते here I और हम लोगों को यहाँ पे अब क्या हुआ. तो फॉर ईच रो टोटल इज NE. फिर any m टाइम्स. तो अगेन पैरेलल में पोटेंशियल डिफरेंस रिमेन सेम. सो NE विल रिमेन as it is. So therefore I is NE upon capital R plus NR by M. It implies that I is NE upon MR plus NR. It implies that I is MNE. हमारे इन दोनों expression both are applicable. Condition for I max, it should be R is equal to NR by M or MR is equal to NR. What my point? Then afterwards unidentical cells, सीरीज में क्या करने हैं, सीरीज में लाइक अब आइडेंटिकल अनआइडेंटिकल है, दैट मीन्स सारे का ईएमएफ ई नहीं होगा। अब E1 E2 E3 सो ऑन E1 E2 E3 E4 R1 R2 R3 R4, therefore I is equal to E1 plus E2 plus E3 minus E4. Considering sum of E1, E2, E3 is greater than E4, tab in that case I will be like this, then R plus R1 plus R3 plus. So this was very simple situation to discuss. अब प्रॉब्लम ही करने में ज्यादा मजा आएगा। अनआइडेंटिकल सेल्स में पैरेलल में अब हमें बात करनी। तो राइट नाउ वी आर इनटू अनआइडेंटिकल सेल्स सीरीज हमने कर लिया। अब आ रहे हैं पैरेलल पे। 5 में से आइडेंटिकल, सीरीज, पैरेलल, फिर मिक्स्ड, फिर उसके बाद मिक्स्ड ग्रुपिंग करने के बाद हमने किया अनआइडेंटिकल सेल्स सीरीज। नाउ अनआइडेंटिकल सेल्स पैरेलल करने वाले, यानी लास्ट E1 R1 E1 R1 R2 B are these 2 points, and E1 will be generating I1 current, I2, and then it is I. Our main goal is to replace these 2 cells by a single one. That means we are to derive for equivalent EMF of these 2 cells. That means if we will be replacing these 2 cells by a single one, then what would be the EMF of that single cell, and what would be the internal resistance of that single cell when we will be replacing these 2 cells by a single cell. I would like to draw quantitatively. We have to find the value of E equivalent and R equivalent. Firstly, already we have I is equal to I1 plus I2, equation number 1. Then also V1 is equal to V2 is equal to V, since in parallel potential difference remains the same. Matlab V1 is potential drop for this cell V1 and here V2, and since in parallel potential difference remains same, so V1 is equal to V2 is equal to V, second equation. Now what do we do? So can we write the equations for V1 and V2 separately? V1 is equal to E1 minus I1 R1, and V2 is equal to E2 minus I2 R2. Using the equations for discharge, and from this equation, from here I1 is equal to E1 minus V1 by R1, and now from this equation I2 is equal to E2 minus V2 by R2. Putting these 2 values of I1 and I2 in this equation number 1, I is equal to I1 plus R. This I am to bring here, and this I am to bring here. Now arranging, it implies that I is equal to E1 R2 plus R1 minus, this time I am to substitute for both V1 and V2 from equation number 2. I was talking about this equation. V by R2 I is equal to V1 R minus V R1 plus R2. I would be referring our diagram in context to this diagram. If I am to write any equation, then we would be mentioning, so V is equal to E equivalent minus I R equivalent. We could refer this equation as equation number 3. And now whatever equation I am reaching, finally we'll have to compare with this equation number 3. Let's see how. That means we have to get the expression for V if we want to compare from equation number 3. it implies that this portion we'll have to bring in left hand side, V minus I. Now simply this portion I am to bring here and here both. That point, this thing I'll be bringing here in right hand side, so that R1, R2 will get cancelled out. R1, R2, what happened to this? Now willing to cancel out. It implies that E1 R2 plus E2 R1 minus I. This is equation number 4, and previously equation number 3 was comparing with this equation number 3 with that of equation number 4. We get E equivalent is E1 R2 plus E2 R1 upon R1 plus R2. Yes, and now I'm about to write this also, R equivalent, because again if we compare equation number 3, then in place of R equivalent we have this bracket. So this is R equivalent and this is E equivalent. So R equivalent also could be written R1 R2 upon proved the desired expression. So this was the expression. But one numerical factor I wanted to introduce, for if polarity in the previous diagram, see, you could notice in both these cells polarity is this way only. But what will happen if these two cells will have reverse polarities? In case of reverse polarities, equivalent EMF would be E equivalent would be E1 R2 minus E2 R1 upon R1 plus R2, and this will remain same because still it is parallel combination only. Hence, grouping of cells or combination of cells is completed. Here in this question, we are given in the network of resistors, we are provided with one capacitor also, and the whole circuit is operated by 10 volt battery, 10 volt cell, and each resistance is of 2 ohms. Okay, each cell and 10 volt, that means E is 10 volt, and what we have to find across this capacitor, potential difference, such that what we should be keeping in our mind that because of this DC circuit, since capacitor blocks DC, no DC could go into, and because of this resistor is also of no use. So finding out potential difference across the capacitor C, we should be finding these and these potential differences. Then effective circuit would be this is 10 volt I1, finally across this here I1 and here I. So basically, if we want to find the potential difference across the capacitor, then that means we have to find the potential difference across this and this, I1 R2 plus I R4. So equivalent resistance would be, this is 2 to 4 ohms, then 4 and 2 are in parallel, 4 by 3 ohms plus 2 more. Therefore, equivalent resistance is equal to 3 to the 6, 4, 10 by 3 ohms. 10 by 3 ohms. It implies that main current, therefore main current is 10 volt battery, therefore I is equal to 10 volt upon 10 by 3 ohm, 3 ampere. 3 ampere. Now distribution of current we need across. We have in upper part 2 plus 2, 4 ohms, here 2 ohms, and main current for 3 ampere. So if in upper branch it is X, then it is 3 minus X. Since in parallel potential difference remains same, so 4X is equal to 2 into 3 minus X, 1 ampere. That means I1 is 1 ampere remaining out of 3, then it would be 2 ampere. So if this I would be, what have I written here? 3 ampere only, right? That means here we have 1 ampere, here we have 3 ampere, then I1 R2 across the capacitor, I1 R2, I1 R2. That means 1 into 2 plus I R4, 3 into 2. 2 plus 6, that is equal to 8 volt is the answer. Very important question. Conceptually also, and it had been asked in JEE also in recent time. That was JEE Main September 20. Then another question I would like to do is, in the given question, potential difference between points A and B are to be found. Interesting part of this question is both the points are located in parallel branches. That's why it is very unusual about it. For such question, we should remember one trick. So I'll begin with that trick only for solving this kind of question. Potential difference related points are located in parallel branches. We have to express these 2 points potential difference in terms of 2 potential differences. The reference point is C. That means we are to express Vc minus Va and Vc minus Vb. First point will be located in second bracket. Second point will be in first bracket. So it should be Vc minus Va and here Vc minus Vb. This is equation number 1. Our aim is to find these 2 potential differences at last. In the given circuit, this is I, and in both the branches, this and this, upper and lower branches, total resistances are 4 ohms only. So first finding out equivalent resistance, then thereafter main current, and main current will be splitted in equally because in both the branches same resistance 4, then 2 ohms. It should be main current I is 10 on 2, that is 5 ampere. Therefore I1, I2 both are equal to 2.5 ampere. C minus Vb. So 2.5 into 3 and is 2.5 into 1. Therefore from equation 1, Va minus Vb is 7.5 minus 2.5 is equal to 5 volt is the answer. So right now we are into charging discharging related numericals after we finished with grouping of resistors. In that sequence, we came across example number 82 from SL Arora, in which the problem says battery of EMF 12 volt whose internal resistance is 5 ohm is to be charged by a battery charger which supplies 110 volt DC. Okay, that means charging source is 110 volt DC. How much resistance must be connected in series with the battery to limit the charging current to 5 ampere? and what will be the potential difference across the terminals of the battery during charging. So in first part, we were to find V across rechargeable battery. For that, which V? Potential drop. This is charging source, external resistance, and then this is storage battery or rechargeable battery. This is charging current, and this is internal resistance. The potential drop across the rechargeable battery we need, है ना? और R के लिए पहले we need I current. I is net EMF total resistance. नहीं, net EMF is, this is 110 minus 12, and resistance में, and I was given 5 ampere, नहीं? And this was, from here we can find the value of external resistance here, 98, 2.5 plus 5R is equal to 98, 96, 95.5, 19.1 ohm. So first part answer. Then second part, what will be the potential difference across the terminals of the battery during charging? Second part, V is equal to E plus IR. E was and I was 5, and then 0.5, 14.5 volt, and hence next question. Now next question, potential difference across terminals of a cell were measured in volts against different currents in ampere flowing through the cell. A graph was drawn which was a straight line ABC. This ABC, otherwise in this category of questions, sometimes 3 cells or 4 cells are also given. Only one cell, and maximum EMF is this, that is 1.3 when current I is 0. Maximum value of V is EMF E. That means it is 1.4. Here maximum value of V is equal to EMF. It implies that E is 1.4 volt. Then thereafter, what is EMF of the cell was asked for. This was first part. Second part, maximum current obtained from the cell. For maximum current I max, V is equal to E. V is equal to E or V is equal to 0. Yes. How come V is equal to 0?
Then I will be equal to E R.
E upon
E into small r.
In general, I is equal to E upon R plus R.
So E will be equal to I when V is 0.
When V is 0, so R is also 0. You want to say that?
Capital R.
And I max from the graph, it is clear that it should be 0.28. Therefore, I max is equal to, but we were to apply something else, therefore minus IR. Here it should be 0, and this E is 1.4, and E was 1.4 upon small r we need to determine, whereas this is 0.28. This is I max. It should be 5. So this problem is also over. Heating effect of current. Let us first understand what is heating effect of current. Whenever any amount of current is passed through the resistor, it dissipates some heat because of obstruction posed by resistor. The phenomenon of the production of heat in a resistor by the flow of an electric current through it is called heating effect of current or Joule heating.